Hello, everyone. Thanks for coming. My name is Kenny Chandrasekera. I work on Rhombus, and Rhombus builds oracles. If you don't know what those are, stay tuned. If you do, we'll be talking about the theory that necessitates oracles and also what they look like in practice and how they can be used. More specifically, here's the agenda. We'll talk about the nature of the oracle problem, how we've chosen to address it, and lastly, some decentralized applications that are currently using Rhombus oracles. Okay, so let's just zoom out beyond oracles and talk about barriers to mass adoption with blockchain. I think everyone can agree that user interface is a work in progress. A lot of people see like wallet addresses when they try to use Ethereum dApps, and we need to be more user-friendly. People are waiting for network effects. If they're considering between a centralized application and a decentralized one, what would cause them to switch to a decentralized application? One advantage would be that the decentralized application in time gains more and more users, and so actually brings benefit to any individual user who chooses to come on board. And then there's also scaling issues. One of them is speed of transactions. Another is number of transactions. How many can we support? This goes hands in hand with the other two bullets up there. And lastly, there's integration with existing systems. This is the one I want to focus on today. It's the one that the oracle problem tries to, well, needs to solve. So there's this quote that paradise is a walled garden, and it might be confusing, but what I mean is that paradise literally means walled garden. The root words for paradise are Indo-Persian, parai and dis, and together they mean to build a wall around. In ancient times in Indo-Persia, people would build sort of an attempt to make heaven on earth. They'd build this magnificent garden and put a wall around it. Why do I bring up this point? So what we've built with blockchains is actually sort of like a walled garden, not in the way that you think of with the centralized powers that run a lot of the internet today, but we've built a set of protocols that, if you follow them, should work as long as you have enough independent actors. What's limited is their uses, unless you have a way to bring in outside data. And that is essentially the oracle problem. You want to take the world as it exists and blockchains as they exist and sort of figure out how to breach this wall. And the way that people conceptualize that is replace like the wall with a moat and build some bridges over that moat. And the bridges are essentially oracles. Why do we call them oracles? This goes back to, it's confusing, but in classical antiquity, an oracle would be a priestess that you could approach at a temple. Journeyers would go there and ask her to divine the truth, tell them about the future. They would take those learnings and then go back to their lives and act on that information. So an oracle is hopefully a less mysterious thing than a priestess, but it will find a way for decentralized applications to act on existing data. But there's like more than that nature to the oracle problem. There's also the problem of defining truth. So here are some questions that decentralized applications might need answered in order to function properly. And if they get accurate or expected answers, they might take a path that leads them to an expected result. But if they get an answer that is sort of outside the bounds of expectation, any number of unexpected results can occur. So here's some seemingly simple example questions. What is the price of Ether in USD? And that's still ambiguous because it depends on what exchange we're talking about. What is the wind speed in Paris? And that again depends on where in Paris. So when people think about how they want to use oracles, they have to become very specific about what sort of answer the oracle will give. You might need to choose an aggregation function to answer these questions, or you might have to be really, really specific about the where, when, why, and how. And those simple questions have a problem which extends to obviously much more complicated questions. Here's one problem from image processing or neural networks that might ask how many clouds are in this photo. And as you might imagine, that really depends. Okay, so here's where Rhombus comes in. Why do we want to call our Oracle solution Rhombus? Well, that's one reason. It's easy to flip and makes a nice shape. But really, it's because Rhombus has 4 pillars. The shape Rhombus has 4 sides. Before I go into how Rhombus fulfills these expectations of these pillars, I want to go over a little bit of terminology. This is like the most word-heavy slide, but I think it's important that we have a common vocabulary if we're going to talk about things and understand each other. So, smart contracts and decentralized applications are programs that are stored and executed on blockchain. Oracles are really data feeds for these smart contracts. I say feed in a sort of loose term that could be something that's delivered once or periodically or conditionally. Rhombus is an Oracle provider, and this just means that Rhombus builds oracles. And here's me attempting to use it in a sentence. Rhombus built an oracle to send the price of gold to a smart contract that allows people to purchase and settle call options. And I'll go into that example a little bit later. So back to the pillars. Accuracy is really important, and this connects to how we defined the problem of truth. You can only be accurate insofar as that you can be consistent and specific with the way you answer any one question that you have. And so Rhombus does the computation of any answer to a question in a consistent way. And this is as close to the truth as we can get. Computability, everyone's sort of grappled with the problem of sending and receiving too many transactions or doing too much computation on chain. This gets really costly, so it's important to find a way to compute as much as possible off-chain and deliver the minimum viable metric for a decentralized application to function. Security goes kind of hand in hand with computability. Once you have that much stuff going on off-chain, you'll be able to show where data comes from and steps of a computation. And lastly, dependability. If you're running any serious application, you need to know that data will be delivered on the schedule that's required. And it might surprise you to know that a lot of Oracle providers don't actually have any delivery guarantees, but Rhombus wants to support people from building your projects on the side all the way up to enterprise-grade applications. And so we take dependability pretty seriously. And then we'll just explore some current applications. OpenLaw used Rhombus to build a decentralized application that allows you to purchase call options. And essentially what happens is user logs in and sees the price of a troy ounce of gold in Ether. Let's say it's 10 Ether. And then let's say they buy the option to purchase tokens representing gold at 11 Ether 24 hours from now. And then 24 hours from now, again, the price of gold is delivered to the app, and the user has the choice to exercise that option that they bought. One of my favorite applications of Oracle's is parametric insurance. Insurance today, especially when it comes to disaster relief, is extremely broken. Often providers of insurance are slow to do payouts. They might fight the authenticity of a claim. And payouts actually might end up being a lot less than the consumer of the insurance originally expected. All three of these were definitely the case for citizens in Puerto Rico who experienced a lot of devastation in 2017 Hurricanes Irma and Maria were pretty destructive, and the founders of Hurricane Guard found out that a lot of them were not receiving the payouts that they expected, and so they decided to build Hurricane Guard, which is a parametric way of providing payouts. Essentially, premiums are paid to a contract, and then upon verification of an insured event, payouts are automatically sent to people who've paid their premiums. So they built some pretty complex models to figure out what wind speeds were on the ground at any given time, and then used Rhombus to process these models and deliver minimum viable wind speed readings to say, okay, yesterday between the hours of 6 and 10 p.m., wind speeds exceeded 111 miles per hour, and that is a Category 3 hurricane. Send the payout. So I guess the stages of actually building and delivering data involve sourcing, computation, and delivery. So I just want to go into a little bit about how Rhombus does that. In terms of sourcing, I just talked about how we can use proprietary data, this time from Hurricane Guard, to deliver to their own contracts. But we can also use best-in-class APIs, and really, we don't prescribe what sources to use. We expect people building the contracts to be able to point to what data source is most ideal for them. Computationally, we can go from the very simple. We talked about calculating price of Ether through, say, a median aggregation function, to something a lot more complex. In this use case, let's say a farmer wants to buy insurance against too much variation in temperature, which could cause destruction to their fields. This is another parametric use case. So over time, we can get readings of infrared satellite data and compute entropy, which, if too high, will result in a payout. So this is something we're talking about doing with Aon and Oxfam and Etherisk, a decentralized insurance platform in Sri Lanka for small crop farmers. And lastly, there's delivery. Everyone has different processes for how their contract executes. In the case of prediction markets, really only a one-time delivery is usually needed. In the periodic use case, like I discussed with the open law options contracts, they get price feed that occurs daily. And then there's the conditional use case, which we do for Maker, and I'll go a little bit more into that right now. So here's a case study in which we have multiple sources. This is for the price of Ether in USD, which Maker uses. So I think up there we've got six different exchanges, and then we do an aggregation that throws out statistical outliers, more than 2 standard deviations from the mean, which results in going from the first histogram up top to the second, and then we can take the median from there. And that is a metric that's delivered every 10 minutes as long as the price of Ether in USD has changed by more than 1%. So this is a case where we have a specific type of sourcing, computation, and delivery. We're live on mainnet today, so I just wanted to point out how you can get started. I will put up a bunch of links to resources later, but essentially the top left is a screenshot of docs, and the bottom right is a contract that you can inspect on Etherscan. As you can see from the age column, this is an hourly feed. And then, so where are we going from here? From sort of more near term to more long term. In the more near term, we'd like a more API-like interface for folks who are used to getting variable results from an API instead of a feed that's sort of constant in the parameters that it takes as input. Secondly, we're really into risk-neutral feeds, and this is sort of like an insured data feed. People are worried about what happens if the data feed takes on an unexpected turn, maybe it doesn't deliver the results it wants, maybe a source upstream goes offline. How can we ensure that the DApp keeps functioning? And so as the product matures, people will be able to price the reliability of feeds and pay premiums for those. And in the case that they don't function as expected, there will be payouts. Most long-term is the concept of a zero-knowledge oracle, where an oracle computes on data that it doesn't understand or know the content of, and delivers the result without any knowledge of its application. So here are a bunch of links that you can use. I'll just leave this up as we go into questions. There's docs, there's a truffle box that we released so that you can mimic the use of a Rhombus oracle while you're developing locally, so that when you deploy to a testnet and eventually mainnet, there'll be fewer hiccups for you. You can find a bunch of sample oracles that we've put up and are live now, and feel free to use these during the hackathon later this weekend. These were useful for a bunch of the finalists in the ETH Denver hackathon, which happened a few weeks ago, and we hope you'll like them as well. There's some dApps that use those oracles, and then at the bottom there's ways that you can follow us and reach us. Thank you.
Hi. All right.
Okay.
On a technical level, what makes Rhombus different than like all the other oracles that exist in Ethereum?
That's a good question. So one, I think, is the ability to provide reliability guarantees. Okay. Reliability guarantees. I guess I won't name names, but some Oracle services are pure libraries that you can drag and drop, but you can't go to them if something happens that you don't expect. They're not considering risk-neutral feeds. They don't make any guarantees and SLAs about response rate and response time. And then there are also Oracle marketplaces out there. They don't build feeds like Rhombus does. They simply want to host them and be a place where you can go buy data feeds.
Yeah, then if you're just like kind of like a normal Oracle, why not, instead of like delivering the services yourselves, be a node that is part of like Chainlink?
I guess there's no reason why you couldn't do that. There are many ways that you can reach an Oracle provider. You can go through a channel like Chainlink. You can go directly to them. I don't think there's any conflict. If you prefer to be on Chainlink, that's totally up to you. Well, it depends what security guarantees you're looking for, but we can provide a digest of all the computations done from original source material all the way to what we deliver for verification. And we can also, go ahead. Well, it's verifiable. You can inspect the source, you can inspect every step along the way, and then you can see if the results that you obtain through this verification process is actually the one we sent. Do you mind if we have a chance to ask other questions? Thank you.
Sorry, that looked like it was getting intense there. Just two quick questions, perhaps. One is, how do you manage the demand versus supply thing, and which one are you trying to put weight on, i.e. demand for particular information and supply of particular information, which don't always match? And the second question is, who's delivering your real-time data? Like, what's your transport layer for that?
Okay. The first question was demand versus supply. What is the focus? How do you balance the two? So I think it's fair to say that we're demand side first. If anyone needs certain data and they can point anywhere in the world that they currently get it, we can turn that into a feed for them. It's less essential that we find suppliers for data that's not currently demanded. Okay. Secondly, you asked about delivery. How does that happen? So we actually have two methods that are available. One is called a lighthouse contract. And in that, a lighthouse contract, that's basically a Rhombus contract on-chain that acts as a cache. It's periodically updated, let's say every 10 minutes or every hour or every day, according to the specifications of the person who's using that contract. For more sensitive data, we can do a direct delivery to the client's contract.
Do you have your own service?
Yes, we do.
You don't use AWS or anything else?
That is agnostic, actually. So if a customer prefers that you use a certain provider, that's fine. But we can also use any of the new solutions that are coming on board with trusted or distributed computation.
Hi, thanks for the talk. It was great. But I was wondering, where does the normalization of the data or the aggregation of the data happen? Is that on-chain or off-chain on the central server?
It is off-chain typically, and that's because people actually prefer that we do it that way instead of them aggregating data on their contract and dealing with the computation there. And again, that can be specified as needed. If people are comfortable with spending less money to do it in just AWS one server, that's fine. But we're also talking to a lot of distributed computation providers.
All right, thank you. It's clear.
Is it working? Like, are people coming to you getting seeing demand, and then you guys do you have a full profit model?
Yeah, we do. So the baseline profit is charging a certain percentage above the transaction cost. But then for more complex computation models, like with, say, Hurricane Guard or the other parametric insurance concept that I discussed, where you have entropy calculated on satellite images, that setup takes longer. So we essentially charge for developer time. Okay, maybe you had one more. Thanks for waiting.
You can't run over time because of the last speaker.
Right, yeah. I'll be here all night, folks.
All right, so I don't know if you're aware of like some of like the oracleizes, technical stuff and all that. So essentially, they have this system for pulling HTTPS data that they use TLS Notary and OS oracles to provide like proof that they have like retrieved data from a point, and like that data that they have retrieved is actually that data that has been served from that endpoint. Mm-hmm. Do you do that?
Yeah. So what most people are satisfied with is getting a root node hashed of a Merkle tree where the leaves are interactions with each source. So essentially, if you have like 6 different sources or 8 different sources for a price of Ether, like different exchanges, you can provide with the leaves of the Merkle tree are the call and response with each API.
Yeah, but that's more like on the sense of auditoring, but not actually proving that the data that you're sending to the smart contract is actually the same data that you received from the data point. Is that right?
So if I read you correctly, if I provide this Merkle tree of source materials and also provide every step of the computation from the source responses all the way to the metric that was delivered, it's possible to verify that we used the correct sources and did all the computations as instructed.
Yeah, but how do I know that the source material that you're saying that you got from that source is the material that you actually got from that source? Like, can you fake that?
I don't know how to fake it, but I mean, maybe you do, which is...
I mean, you're providing like the inputs to the computation, but like you could say, hey, we received like that information from that data source, and actually you could have received something else, and then like the whole computations and all that would be actually wrong. So essentially, at the end you're delivering a fake result.
I'm not sure I understand, but I guess we have our tech lead in the house, and maybe I can get you to talk to him afterwards.
Okay, cool.
Okay. Thank you. Thanks, everyone.